This is Dr. D. Khalandar Basha, working as Associate Professor in the Department of ECE, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today I am going to discuss the architecture of 8086 microprocessor. The slides are prepared by referring the textbook Advanced Microprocessors and Peripherals. Authors are K. M. Budchendi and IARE. Publication Tata Background. The architecture of 8086 supports a 16-bit ALU, a set of 16-bit registers, provides segmented memory address capability, a rich instruction set, a powerful interrupt structure, fetched instruction queue. The internal block diagram of 8086 is shown in figure 1. The architecture of 8086 processor is divided into two functional units. One is bus interface unit. The second one is execution control unit. Here, BIU stands for bus interface unit. The second portion is EU, which is execution unit. The bus interface unit contains the physical address calculation, instruction queue. This unit responsible for establishing communication with the external devices and peripherals. The execution unit contains the register bank of 8086 except instruction pointer. It contains 16-bit ALU, a 16-bit flag register, a decoding unit and timing control unit. Here, this block, it is used for a generation of the physical address of memory by using the segment register address, then offset value. For generation of physical address, the formula is segment address register multiply with the 10H multiply with the offset value. The segment register address can be fetched from any one of these registers: code segment register, stack segment register, data segment register, extra segment register. Whereas the offset values will be fetched from the pointers or index registers or to the instruction. Whatever the address which it is generated, this address is used for fetching the data from the memory, or if it is IO transaction, the address of the IO devices will be passed through this address bus. If the data or information, if it is fetched from the code memory, the data will be stored in the instruction queue. Where the instruction queue is 6 bytes free fetched queue. The execution unit is consist of 4 general purpose register: AX, BX, CX, DX. For 8-bit application, these registers we can use as AH and AL register, BH, BL register, CH, CL register, DH, DL register. So in total, there are 4 16-bit registers, namely AX, BX, CX, DX. If it is 8-bit applications, we can have 8 registers: AH, AL, BH, BL, CH, CL, DH, DL. Apart from that, 2 pointers: stack pointer, base pointer, and 2 index register, that is source index register and destination index register. So all the register banks are available in the execution unit. Apart from this, here we have a control unit. The control unit will send the necessary signals for the internal blocks of the 8086 processor. The next block is ALU, which stands for Arithmetic Logic Unit, where we can perform all the arithmetic and logical operations. For each operation, we may require 1 operand or 2 operands. The operands will be sent through the data bus. After executing the operation, depend upon the instruction, the result will be fed back to the bus. From this bus, the data may be stored to the registers or it may be stored to the memory. Depending upon the results of ALU, the flags will be affected in the flag register. This is the block diagram of 8086 architecture. The bus interface unit generate a 20-bit physical address by using a segment register and offset value with the help of adder. The bus interface unit also contain a 6-byte instruction queue, provides the overlap fetched and execution cycle. It have the first in first out structure. When the fetched instruction is executed internally, the external bus is used to fetch the mission code of the next instruction and arrange in queue known as pre-decoded instruction byte queue. With this instruction queue existence in the 8086 processor, the processor is having the pipeline architecture. The next one is execution unit. The execution unit gives instruction to bus interface unit starting from where to fetch the data and then decode and execute those instructions. Its function is to control operations on data using the instruction decoder and ALU. The decoding unit decodes the opcode bytes issued from the instruction queue. The timing and control unit derives the necessary control signals to execute the instruction opcode received from the queue. Execution unit has no direct connection with the system bus as shown in the figure. It performs over data through bus interface unit. In 8086 processor architecture, we can see general purpose registers. There are 8 general purpose registers of size 8-bit, namely AHAL, BHBL, CHCL, DH and DL, and can be used in pairs to store 16-bit data. The valid register pairs are AHAL will be paired as AX register, BHBL will be paired as BX register, CHCL is paired as CX register, the DHDL is paired as DX register. It is referred to the AX, BX, CX, DX respectively. The AX register is also known as accumulator register. It is used to store operand for arithmetic operations. BX register, it is used as base register. It is used to store the starting base address of the memory area within the data segment. CX register, it is referred to as counter for few instruction. It is used in loop instruction to store the loop counter. DX register, this register is used to hold the IO address for in-out instructions. Segment register, this register will hold the address of the starting memory location in the segment of memory. There are 4 segment register: code segment register, data segment register, stack segment register, extra segment register. The CS, code segment register, it is used for addressing a memory location in the code segment of the memory where the executable program is stored. DS, data segment, it consists of data used by the program and is accessed in the data memory segmentation by an offset address or the content of other register that holds the offset address. Stack segment, it holds memory to store data and address during execution. Extra segment, ES. ES is additional data segment which is used by the string to hold the extra destination data. The next we have pointers. The pointers will hold the offset address of the segment of the memory. We have total 3 pointers: instruction pointer, base pointer, stack pointer register. Instruction pointer register, it is a 16-bit register used to hold the address of the next instruction to be executed. Base pointer register, it is a 16-bit register used to hold the address of the data, that is offset value. Stack pointer register, it is a 16-bit register which hold the address from the start of the segment of the memory location where a word has mostly recent stored on the stack. ALU. ALU is a 16-bit size. It will handle all arithmetic and logical operations like addition, subtraction, multiplication, division, logical or logical and logical not operations. Flag register. It is a 16-bit register. It changes its status according to the results stored in the accumulator. It has 9 active flags. They are divided into two groups, conditional flags and control flags. Conditional flags, it represents the result of the last arithmetic or logical instruction is executed. Following is the list of the conditional flags: carry flag, auxiliary carry flag, parity flag, zero flag, sign flag and overflow flag. The next one is control flags. The control flags holds the operation of the execution unit. Following is the list of the control flags: draft flag, interrupt flag and direction flag. Thank you all. So in this session, we have discussed the architecture of 8086 processor. The 8086 processor is a 16-bit microprocessor which is consists of 16-bit ALU. The architecture of 8086 processor broadly divided into two blocks: bus interface unit, execution unit. In the bus interface unit, the data will be fetched from the memory to the memory by using physical address calculation. So the bus interface unit is responsible for communicating the IO devices or memory with the processor. Execution unit is responsible for executing the program depending upon the instructions which are there in the code segment. In the bus interface unit, we are going to have the segment registers like code segment, data segment, extra segment and stack segment register. Apart from that, we have one instruction pointer. The next block it consists is a physical address calculation by using segment address and offset value. One more block it is present, it consists is a free-fetched instruction queue. Whenever the bus is free, the next instruction to be executed will be fetched from the code memory into the instruction queue. Whatever the instructions are executed, that will be decoded by the decoding mechanism, and the control unit will send the necessary signals required for all the blocks of the 8086 processor. The execution unit is also consist of a 16-bit ALU, a 16-bit flag register. Apart from that, 4 16-bit general purpose registers, that is AX, BX, CX, DX. We can also use for 8-bit applications. In that case, we refer the registers as AHAL, BHBL, CHCL and DHDL. And we have 2 pointers in the execution unit, that is base pointer and stack pointer, and it consists of 2 index registers, that is source index register and destination index register. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.